Polkadot as a solution to scalability with Andre from CoinTelegraph, Sota from Plasm, Joe from the Web3 Foundation, and Derek from Moonbeam. I'm going to bring them all on now. This might be the most geographically distributed panel of the day. Where's everyone at? I'm in New York. Andre, Joe's in Zoo.
Yeah, I'm in Italy.
Sota.
Singapore right now.
Derek in Boston. Well, we're actually pretty close. This is going to be a good one. So to discuss Polkadot as a solution to scalability, an all-star panel, Andre, take it away.
Thank you, Peter. So, well, I wanted to, first of all, introduce our guests here. So I am Andrei Shevchenko, technology editor at CoinTelegraph. I'll be moderating the conversation today. And we have with us Sota Watanabe, the founder of Plasma Network, a layer 2 focused project building for Polkadot, which is super interesting. Then we have Derek Yu, who's the founder of Moonbeam, basically an Ethereum and Polkadot project, so to speak. And finally, we have Joe Petrovsky, technical integrations lead at the Web3 Foundation. So we don't have too much time, so I wanted to get right to the point. I think, Joe, the first kind of question will be to you, because it's kind of the best to set the stage, I feel. And the question is, what makes Polkadot scalable in a nutshell? So we know there's parachains, but also are there any other aspects that make Polkadot more scalable than others, essentially?
Yeah, so like you said, parachains are kind of like the main avenue towards scalability. So this idea of shifting logic into parallel execution rather than having everybody kind of share the same chain. And so that kind of gives you like a linear scalability where, if you add double the parachains, you get kind of double the transaction throughput, with the assumption that like every parachain has the same transaction capacity. But then the other approach here is just the idea that the projects actually code the parachain logic themselves and the runtime logic. And the reason that's important is that when you have an application and the developers kind of choose like this logic as first class, like layer 1 logic, this is actually in some sense trusted, right? Because like as part of agreeing to use this blockchain, you've agreed to trust this logic. Just like when you use Ethereum, you agree to use the EVM and you trust that the EVM is actually sound. You don't trust that the contracts on top of it are sound. And so that's where like kind of all the gas metering and this stuff comes in, is that in order to let people deploy these like permissionless contracts onto your platform, you have to have some way to meter it or something. But in Polkadot, like if you have a lot of activity going on one parachain, it's not going to affect other parachains. So we can just say like, hey, if you have your parachain slot, you can put kind of whatever logic you want there. And so in that sense, it can be like this trusted logic and doesn't really need to be metered. You can have kind of like a better fee mechanism where you just say like, hey, we know that, for example, like a lending contract or something, like we know it just does this number of steps, so we just charge a fee for it. Like if you have something like say Compound on Ethereum, you know what the contract does. It's executed hundreds of thousands of times. Why are you metering that if you already know exactly what it does? And so with Polkadot, like the idea is that you can just put this logic like right into your parachain and you don't need to meter it because this logic is trusted, it's benchmarked, it's tested. So yeah, like you said, the panel's short. I don't want to keep going on that, but the parachains and then this idea of like trusted logic in your parachain.
Yeah, I mean, like that's an interesting topic that you discussed, because I'm personally a little bit curious. Like there's the sharding concept, the parachains, but what is kind of the maximum performance limit of a parachain itself, like a single parachain simply? Maybe Derek can answer that as well.
Sure.
From his experience.
Sure. I mean, I would just to echo or to kind of tag along with some of Joe's thoughts. I mean, for me, this sharding idea is kind of the key idea, and it's kind of interesting. A bet on Polkadot is a bet on this sharded execution in some sense, and I think it's interesting because it was the case that Ethereum was pursuing a similar path, but that's recently that's changed now, right? Where only some parts of the ETH2 plan now are sharded. Particularly and specifically execution is like not the current plans are that it won't be sharded. So I do think that Polkadot represents kind of the purest form of this, like let's just have these like fully independent threads of execution going and allow them to interact with each other. So I do think that's kind of an interesting point. each shard like itself is just a blockchain. So, there's no kind of like magic, I'd say, where somehow you can defy the laws of gravity. Like, each shard is going to be its own blockchain. It's going to be subject to the similar constraints to other individual blockchains. But, the second point Joe made is important, that, this substrate development framework that one has, does allow for, the ability to specialize those chains and optimize them to the use case at hand. And so, that's obviously what in my mind is kind of the second, key thing around Polkadot is that ability to customize. You don't see like in other sharded systems, and that allows you to at least be as efficient as you can be, and kind of express yourself. Express your kind of unique idea when it comes to what it is that the shard is going to do.
Yeah, I think it's a very interesting concept in the sense that you guys chose to basically express Ethereum, right? So, and here I wanted to kind of follow up another aspect that I feel is important in kind of this scalability discussion, which is the EVM, the virtual machine, right? So, I guess this is, again, the best question for you, Derek, but do you think there are significant differences between the EVM and the WebAssembly framework in terms of scalability, essentially? Is one better than the other?
Yeah, I mean, it's well, I guess I would say this in the context of Polkadot, it's not like a EVM versus WASM, because Polkadot itself is WASM based. So and it's while it's true that so our this kind of uniqueness point I was talking about and specialization, we've chosen to create our specialized chain to be Ethereum like, right? So then that's I think Rob once said, it's like, oh, you're specialized in your generality, like, so you're creating this general thing, but it is still kind of specialized in a way. But just for folks in the audience here, just to make the point, even though we've created this, let's call it like this Ethereum emulation layer, and we're trying to create this Ethereum-like experience, like as part of being a parachain on Polkadot, that logic will all get compiled down to like a WASM binary. And WASM is heavily used in the design of Polkadot itself. So even though we're kind of offering this like EVM-like execution environment, that becomes a WASM binary. That's then registered to the relay chain, and then relay chain validators are kind of like loading that like on the fly to be able to like provide security services, right, for our parachain when we launch. So it's kind of like I guess it's not an either or. It's kind of like a EVM plus WASM, I guess, in a way, is the way I see it.
Yeah, and in addition to that, we are implementing a scalable multi-virtual machine parachain that support layer 2 protocol. So Polkadot parachain can support both with Ethereum virtual machine and WebAssembly. So it's not just like a trade-off.
Yeah, absolutely. But I mean, to me, it's just interesting. Would projects why would projects use the EVM essentially? So are the drawbacks, for example, bigger in terms of performance with EVM, but maybe it's more familiar to use for dApp developers? So what do you think, Soda?
Yeah, I think currently Ethereum do have a problem, and the gas cost is very expensive. So they would like to migrate from Ethereum to another chain. Yeah, like Polkadot. So Ethereum compatibility is really important tool to migrate. Basically, Ethereum developer, so I can say Solidity contract developer can deploy Solidity contract on the top of Polkadot parachain, let's say like Plasm and Moonbeam. And I think that's why we need Ethereum virtual machine in the short run. But I personally believe WebAssembly in the long run.
Interesting. So, I mean, speaking of Ethereum, so I guess as Derek mentioned, Ethereum is going on this very roll-up centric, layer 2 centric scalability solution essentially, and actually Plasm is kind of doing the same thing but for Polkadot. So do you think Ethereum is going in the right direction in this sense? For example,
yeah, thanks for the question. So one of the frequently asked questions from the community is why we are implementing layer 2 solution. And the Polkadot itself is a layer 2 solution, right? But we are implementing the Polkadot parachain for billion of people. And the Polkadot is scaling solution, but it's not enough. And the horizontal scalability is different from vertical scalability. And we are implementing vertical scalability, which is more flexible and which can be faster and in terms of transaction and finality. And I think Ethereum project will be using optimistic rollup or ZK rollup in coming months. And we do support rollup solution right now. So we have got Web3 Foundation grants, and we have already submitted some of the milestone of ZK rollup. So ZK rollup developer can migrate from Ethereum to Polkadot by using Plasm, and they can make multi-chain application by using rollup solution on Polkadot.
It's very, very true. And Joe, I wanted to come back to you here for a bit. So Polkadot, as you mentioned, it has the parachains, it has the sharding. So do you think that layer 2 is kind of important in this overall picture of, let's say you have a lot of parachains, but you also boost them through layer 2, and is that going to be like the ultimate scalability network?
Yeah, I mean, it's definitely possible, like what Soda is working on, to have like layer 2 options on Polkadot. I would say, like, for us, it's not our main focus. Like, our main focus is just having the best layer 1 experience possible. So like Polkadot, the relay chain is layer 0, and it's just really like a WASM execution engine where you can have like the EVM or some other chain. And we want to make that like as efficient as possible to support as many parachains and parathreads as possible, and like eventually have this kind of like nested structure where you can actually have parachains be relay chains with parachains kind of underneath them, which kind of gives you like more layer 1 scalability as well. So yeah, I think I wouldn't rule out any solution. I mean, we haven't really seen like layer 2s in production yet, and there's certainly a lot of concerns, like if we have multiple layer 2 networks on a single Ethereum chain, like, well, can applications in various layer 2s even interoperate without like going back to reconcile on the Ethereum main chain? So there's obviously like hurdles to be solved with layer 2, just like there are with layer 1. And yeah, I wouldn't rule out layer 2 on Polkadot as being part of the overall stack. It's just not really like where our focus on like the core protocol team is.
I'll just jump in on that. Just to, the way I see it is that like these layer 2s. I mean, it is kind of multi-chain as well, right? I mean, these are just, in my mind, a lot of these layer 2s are just other chains that are they're very tightly integrated with the chain that they're sitting on top of, and they're highly optimized for certain use cases, like transaction throughput in the case of ZK rollup, for example. But it is kind of all just different forms of multi-chain in a way. So I think that the layer 2 kind of architecture and setup is like one approach, but you may be able to achieve some of the same benefits or effects via cross parachain integrations, this kind of thing, right? So I think it's all kind of like different forms of multi-chain. And for me, it's like, I know it's been mentioned a couple times. It's like the interoperability is kind of like the key point. I mean, Joe mentioned it as well, that it's my belief that obviously transaction throughput is great, and it opens up new use cases and allows us to scale to like larger numbers of users. But if it comes at the cost of interoperability, that's a pretty steep price. And I think people are starting to understand this even on Ethereum, that you solve the scalability problem, but it's hard to like layer on the interoperability like after the fact. I think, and that's I think a strength of Polkadot, right, is that it's kind of designed into the system itself, like at this kind of base layer. And that to me is like that was one of the attractions like to Polkadot in the first place, I think, right? That it's kind of this idea of like it's designed in at the base layer, and you're not trying to like add it on after the fact.
Yeah, absolutely. I mean, it's also an interesting kind of discussion point, which is, can Polkadot essentially act like as layer 2 for Ethereum itself? Maybe the interoperability is kind of the key to that, right? But do you see that actually happening in the near future, I guess? Derek?
Yeah, so, well, I mean, I guess there's kind of, in my mind, there's a little bit of the short term and the longer term. So, this interoperability is kind of one of the key drivers, for us, and what led us to Polkadot in the first place, as I mentioned. And there's kind of, I would call it like Polkadot fit for us, like the Polkadot facing native integration, we're quite excited about, but I think it's going to take a little bit of time for that to unfold. And, obviously not every chain is a Polkadot parachain, right? I kind of see it as like when we're facing kind of the outside world, then it's the EVM and this Ethereum tech stack is like, is what, the most effective way to kind of integrate with these other chains, right? Including Ethereum, right? Because almost everyone out there already has Ethereum integrations, right? Or has some level of connectivity to that chain. So, by having that be the kind of external facing, integration, interfaces. I think that's, cast the widest like kind of net possible. But in the longer run, I'm kind of pretty bullish on like what's going to be possible with like a native, multi-chain applications on Polkadot, right? Where, it kind of goes back to that old like, Unix philosophy where like you do one thing and do it well, right? So you have these chains that are all doing their thing and doing it well, but then you can combine those like tools to like achieve some like larger effect. And I'm not exactly sure what form that's going to take. I mean, there's just kind of these little bit of baby steps happening now where, people are working on using XCMP to power token movement scenarios. But, I'm pretty sure that there's going to be these like richer possibilities on the Polkadot native side to create applications that, may live across multiple chains, but, they're presenting somehow, kind of one experience to the user. And so that, that's a little bit futuristic, I think, but I'm pretty excited about that like idea.
Yeah, I don't think you can have like one of these networks as a layer 2 to the other if they have separate like security guarantees or like finality mechanisms where like the idea of like layer 2 on a network is that if there's some dispute, then it comes back to layer 1 to settle that. And like if you have Polkadot saying something is final and then somebody kind of like contesting that on Ethereum, that doesn't really work. And so, you're kind of like trusting whatever consensus system you're operating within. And so I think like to like carry on Derek's like Unix analogy is like, actually you kind of have like these different, like security is a scarce resource. So there's a limited number of like independent consensus systems out there, whether they're proof of work or proof of stake. But you kind of end up in this like operating system environment where there's like, Linux, Windows, and Mac, and some others. I think there's going to be like a couple big ones with programs that interoperate between all of them, but it's not like one of those is a layer 2 to another one, right? They're just like 3 different choices that you have to deploy on top of.
Yeah, it's very true. I guess there's always going to be a degree of connectivity, right? Like you can transfer tokens, but probably not interoperate dApps. I just have this question that is kind of interesting to me is that what can Polkadot not do in the sense of, is there kind of a limit to latency that you can reach or a limit to how many parachains you can deploy? Like, is there kind of a higher limit essentially to scalability on Polkadot?
Yeah, so like it sort of depends. So we need like, some number of validators per parachain. And so we have some mechanisms in place. So like, like with traditional BFT algorithms, they kind of scale like quadratically with the number of participants. So, with like Grandpa, we can kind of finalize blocks in batches. So, we can kind of like decrease this by a linear factor. Like if you want to say like, well, yes, we have like quadratic complexity, but we are going to finalize like 10 blocks at a time. So we can kind of like do these in batches rather than like waiting to produce the next block on top of that. So there are some like practical limits to like how many validators you can have, but like we do have some mechanisms to kind of like stretch that a little bit. And then we have these other mechanisms, like economic mechanisms, like parachains versus parathreads. So we say like, well, we're going to like reserve the maximum scalability and throughput for the parachains, but we also have like this economic mechanism for parathreads to come in and get a little bit less throughput and share that throughput amongst themselves. And then we have this like Polkadot 2.0 idea of like the hierarchical relay chain. So you have like relay chains of parachains, and that kind of like scales in some sense infinitely. Because if you can have like a relay, if you have the abstraction of making like a parachain a relay chain, well then you can just make the next parachain of that relay chain a relay chain, and you can kind of like keep going with it. Of course, like if you wanted to send like a cross-chain message from like the 5 levels down in this to like another chain 5 levels down in its relay chain, then that might take a while. So I don't think there's like a lot of limits to scalability in that sense. I think some of the application development will change paradigms a little bit. So like on Ethereum, everything is kind of like meant to like, all the applications are kind of like built around synchronous execution. So like if you have like some contract, call another contract, call another contract, the whole thing gets executed synchronously. Whereas like, so you can do things like flash loans and whatnot. Whereas like if you want to do that in a cross-chain environment where these messages are async, you kind of have to build this around, well, we're going to like execute this block, send off a message somewhere else, they're going to do something, execute a block, and send back some message to tell us what happened, or maybe not. Maybe we just kind of like watch that chain and look for it to happen there. And that just kind of like changes the application programming paradigm, where like you could still do something like a flash loan, but maybe it needs like something like a mutex or something where you execute this block and you just kind of like hold on to it and say like, well, pause here. We're going to send off this message to this other chain, let some other stuff happen, and it's going to come back, 6 or 12 seconds later with some result, and then we can release that mutex and let it go. So you just kind of, I would say like there's not a lot of limits on exactly like how far the scalability goes, but some of the paradigms that people build applications in will have to change to kind of like deal with having this multi-chain environment.
Yeah, it's very interesting. I guess that's the whole async pattern that's changes a lot of things. Soda, I wanted to ask to you, maybe you can pitch in as well. Do you think that, especially maybe with layer 2 solutions, you can somehow overcome a few of this, like some limitations of, let's say, having to reach consensus on every block?
Yeah, so the point I would like to mention is the layer 1 scalability and layer 2 scalability are totally different things. In terms of Polkadot do have a layer 1 scalability because which has the sharding architecture. But if I understand correctly, the parachain have to be a block chain, which is developed by on substrate at this moment. In the future, which can be different, but at this moment, parachain have to be a block chain. And the decentralized application deployed on the layer 1 blockchain heavily depends on the layer 1, right? But in case of the layer 2, which can be an off-chain solution, does not rely on the layer 1. Security rely on the layer 1, but layer 2 has flexibility because layer 2 can be centralized, but it's going to be trust-free. So I personally believe many people will use the layer 2 on Polkadot as well, because layer 1 scalability and layer 2 scalability are different things. But no one knows.
Yeah, absolutely. Derek, did you want to add something to the discussion as well?
No, I mean, I would say, obviously part of the power of Polkadot for me goes back to that specialization idea. So, I mean, you look at other sharded systems, almost all of them, generally tend to have all the shards the same, basically, right? So there's some choice that's made from the designer's point of view. They're using sharding as a way to parallelize execution, but they've kind of decided, like, yes, it's going to be n number of these things. And so I think that, just the fact that we're even here having these like different ideas about like in different implementations, that's like part of the adaptability and power of Polkadot, right? That you can use Substrate to express these different ideas, and then, in some sense, I think then like it's all an experiment, and you can we can see like which ones are the ones that developers get attracted to, that find product market fit and other things. I do see this kind of adaptability and ability to evolve over time is like a great strength of Polkadot.
Yeah, absolutely. I wanted to, I guess we kind of finished the main discussion, I think, but there are a lot of interesting questions from the community, so I wanted to read a few of those, and maybe we can answer them. You feel free to send them in a chat as well, just normally, but there's also a fancy system to kind of upvote them and stuff. So the most upvoted question for now is actually that parachain slots are only valid for 2 years. Why 2 years, and what happens to the projects? Asked by lol. So maybe Joe, this is probably best for you to answer.
Yeah, so I can't say why exactly 2 years was the value that people chose, but yeah, so parachain slots are limited, and kind of like as we discussed before, you need like some number of validators per parachain to actually execute them, and so we don't want to keep around projects that are kind of like there might be like another project that's more valuable than like a failed project that will come in to like take its spot, and there needs to be some way to have like parachain churn, and that's parachains exit and new ones come in. So like there should always be like an opportunity for parachains to come in, and actually like what we're looking at is so none of these timelines are final or anything, but like we're kind of looking at auctions to be about 2 weeks long, and having like maybe like 50 parachains allocated by auction and 50 parachains either common good or like para threads. And so like you can kind of map this out that if you do like, there's 52 2-week periods over 2 years. So if you just kind of have like always have an auction going, then you would actually go through all 50 of those parachain slots in 2 years. And there would always be a parachain auction going on to allocate that one slot for the next 2 years. So there is this idea that like there should always be an opportunity for a project that has enough like whose backers think that this has enough value to be able to come in and join Polkadot. So that's kind of like the reason why they do have like some kind of like fixed term and not being indefinite. And what projects do is, I think that's probably a better question for Derek or Soda to answer, but there's quite a lot of strategies. There's like kind of like this crowd loan concept to do the initial funding, but then also like a lot of longer term sustainability ideas that are coming from the ecosystem where like rather than doing like these like crowd loans like every single time, some ideas to like actually make a project self-sustainable. So I'd actually hand it over to the other two people to talk about some of the ideas that they have.
Can you go past Derek?
Sure. I think that the crowd loan, as you mentioned, is a kind of definitely being used by a lot of the teams that I've spoken with for the initial bootstrapping. And then I think, an idea that was popularized by Akala is kind of an idea that, ultimately you want like the chain to become kind of master of its own destiny. And so there's some form of basically accrual of assets like on the chain that might don't belong to any particular person, but are kind of more chain owned like assets that could then be used in the future to kind of perpetually secure a spot. I've seen several different variants of this idea. We're employing, an idea like that, but I think that's this kind of like a self-sovereignty, I guess, for the chain itself is I think a goal that a lot of the teams I've talked to have.
Yeah, there's a lot of ideas.
And in addition to that, after the 2 year, we have to bid the slot again. So we have to make the portion to bid the slot. So I think many projects will make a treasury or using some sort of transaction fee for the future auction. But I think the first auction will be the most expensive one. So many projects prepare, let's say, 10% up to 35% for the auction. But after connecting our blockchain to Polkadot, we have to make the on-chain treasury or some sort of funding mechanism to become a Polkadot parachain again after the 2 years. So this can be a really interesting question for the community and ourselves.
Yeah, that's definitely a little bit off topic here, but there's actually another question that is also highest vote, but it's a bit generic, but let's see what we can do in the limited amount of time we have. So Polkadot versus Ethereum versus ADA or Cardano. What are the actual differences between them, and why would one be superior to the other? Can all three live together in peace, or only one will survive in the long run? So the floor is open. Maybe Joe, if you want to start.
Yeah, I'd like. So Polkadot's quite different from both of them. So I'm not up to date on what the latest latest Ethereum 2 plans are for Ethereum. But kind of like this homogeneous sharding model, or some like scaled version of ETH1. Either way, it's still like a smart contract platform. So it has this like one runtime, which is the EVM or EWASM or kind of whatever ends up being decided on. And it just says like, you can program smart contracts on this and deploy them here. And that's kind of like the path for Ethereum. And Polkadot, like as we discussed, it's also like a sharded model, which would be comparable to like ETH2, except instead of this homogeneous shard where it's like the EVM on every single shard, it's you design your own shard and you're not sharing it with anybody else. It's your parachain. And then Cardano is also a smart contract platform, and it has these like side chains, but they're not really like independent layer ones. Like, so they can kind of get these like independent verifiers, but they're actually like the Cardano side chains are a lot more like a layer 2 solution where like they don't have any kind of like inherent security. It's kind of like this trusted validator set. And then if somebody has like an argument about it, then they can kind of like, raise it to the layer 1 chain and settle it. But they're really not parachains. It's not like a custom chain. It's just like your own like layer 2 for your application. So yeah, I think like we hope that Polkadot is successful, but yeah, I think those are like kind of the high level architecture differences.
Yeah, and what's I did another one, which is Cosmos. I guess it's kind of the closest in terms of architecture, but what are the differences with Polkadot?
Yeah, so Cosmos is like quite different in its architecture in that it's not sharded. So it's just all these like independently secure chains, and then they provide like a bridging mechanism to send messages between them. So you're still kind of like, this is kind of different from like ETH2 and Polkadot being sharded, where like they're sharing some kind of like contextual guarantees about their consensus and execution. Whereas in Cosmos, you can send messages, but you kind of have to trust the sender of that message, that chain didn't get attacked or forked or reorged or something like that.
And also regarding the Cosmos and Polkadot from the parachain builder's view, so if we connect our blockchain to Polkadot, we can import the security, which is called like shared security. But if we make blockchain with Cosmos, we have to prepare the security by ourselves, which will be very difficult for a small project. So yeah, that's why we chose the Polkadot 2 years ago.
Yeah, absolutely. I guess, I don't know, it's not super kind of informed on Cosmos. It's the whole Tendermint thing. I thought it was like supposed to be the same consensus mechanism, but I guess it's not quite the same. Derek, maybe have this question that came up. Would you say that developing on Substrate but not connecting to Polkadot is kind of the same thing as basically being a chain on Cosmos?
And again, I spend most of my time in Polkadot, so I'm by no means an expert on Cosmos, but and I've made this observation actually a couple other times in recent days here. To me, it's just kind of like a different philosophy, like kind of what Joe was mentioning, right? So in Cosmos, they kind of want this like idea that everyone is self-sovereign, and then we kind of optionally have these like connection points or communication channels like we establish. And it's kind of interesting to me that even if I think that there's like, I've talked before about how there's sometimes a connection between like the structure of a piece of software and then the organization that's kind of like either creating it or around it. And I get the sense that, in the Cosmos ecosystem too, there's more like teams that are more dispersed basically. I think they're almost like the organizational setup fits like the software that got created. It's like this more dispersed, like individual kind of groups that are kind of optionally choosing to make connections with each other. That's pretty different than the Polkadot vision, where I see it as like it's a much more kind of structured piece of software, and then the organizations around it it kind of forces then teams to kind of organize themselves in a way around this like software structure in a different way. And it's I would say that this is actually like one we were also similar to Sota. We're kind of we were faced with a Cosmos versus Polkadot choice when we started our project, and I think this kind of concept that there's like more structure in Polkadot was something that attracted us, because I think my belief is that it's going to make cross-chain interaction patterns like easier to implement, and because it kind of forces you. You can already see it happening. A lot of the teams in Polkadot are already kind of like working together, pretty closely, because of the way the software works. So that's kind of my
point. So like Polkadot's like really focused on this like shared context concept. So when it comes to like security guarantees, there's only like a finite amount of security in the world. Like in proof of stake blockchains, it's like value at stake. So if you start to have like a bunch of like independently secured blockchains, then the amount of value kind of like naturally gets diluted amongst them. And that's like inherently competitive. Like a bigger chain will have the incentive to attack its competitor, startup smaller chains who are kind of like coming and trying to take its market share. So Polkadot would be like kind of like the you could kind of think of it as like an analogy of like the UN or like NATO or something, where like the individual parachains have their own governance systems. They can have their own like economics of like taxation, if you will, like transaction fees or whatever, and their own like languages and like institutions and structures, and their own ways to like make changes to those systems. But they also share this like common like trade or like security agreement where like they have some context that they're operating in, some way to like get together and make decisions, but they still do have like a lot of autonomy and ability to like customize their own, you know, culture system or however you want to call it.
Yeah, it's definitely a kind of interesting model there, but I think that's our time has come up. So
that was an excellent place to end it, Joe, as always. A real pro. Thank you, Andre, Sota, Derek, and Joe. A really interesting panel. Thanks for getting to some of those questions from the audience. I'm sure everyone really appreciates it. And I hope you guys have a good rest of your week.
Thanks so much.
Yeah, thanks.
Thanks for
Thank you,
having
guys.
us. Bye.